So a lot of people think of geomatics as just surveying. You know the person you've probably seen those people at the side of the road with the tripod looking through the little instrument, right? A lot of people think that's surveying, and surveying is geomatics. Surveying is part of geomatics, but geomatics is a much broader discipline that goes well beyond just field surveying outside. So for instance, as a geomatics engineer, I do very little of that type of surveying behind the tripod. Most of my work is involved with airplanes and cameras mounted within airplanes, drones, and laying out positions and boundaries through other means that are perhaps a little bit more non-traditional. So geomatics encompasses all that kind of location and boundary determination, but it also includes things like all the data processing. So it's like building 3D point clouds and building maps and things like that. So in the geomatics program, we've had a lot of different people go off and do many types of different things. Some people go out and become surveyors, but other people we've had go work for Google Maps. Other people work for some GIS companies that build maps and do analytics for things like customers and marketing and things like that. We've had other students that get jobs going up in airplanes and flying, maintaining the cameras and running the cameras that are in the airplane. So it's a very broad scope, and it's one of those programs at SAIT that is kind of unique in my mind, because there's so many different things you can do with that diploma. Okay, there's virtually everything in the world needs some kind of a location or a position, and that's where a geomatics technologist would come in. So that's the nuts and bolts of geomatics. Does anybody have any questions about that? Mike.
So if I take this course, what kind of wages can I expect if I get really good at it?
Well, I guess it depends on like I said, the scope of the discipline is quite broad. So, there's there's quite an abundance of terrestrial, traditional surveyors that are outside working behind a tripod, but there's also a lot of parts of that industry that are quite undersubscribed. For instance, a good example is drone pilots. Right now in the survey industry, there's a big shortage of drone pilots. And if you got in with most engineering companies hire people to fly drones. That's all they do all day long. And if you're in that kind of a situation where you have those skills, you could probably expect wages right out of school somewhere between $50,000 and $60,000 a year. And then as you get more experience, those wages go up quite quickly. So that's, it kind of depends on where you want to go with it. It's, if you go into things like cadastral law, like laying out boundaries and all the legal part of it too, as a plan checker, things like that, probably a lot of those same types of wages. But it is a fairly good paying discipline. And our graduation, our higher employment rate after graduation is around 99%, and most of our grads have job offers before Christmas. So a lot of people, like we have some geomatics students here today with us already that they haven't even graduated yet and have multiple offers. So it is a very industry that needs people. So something to think about. Any other questions? Yeah.
How long is the program?
2 years.
And is that geomatics and you have to specialize in drones or anything?
No. One nice thing about the geomatics program is it's a very, very well-rounded program in that we give you equal training, not just on a traditional surveying instrument, but LiDAR scanners, how to build point clouds, how to build web maps, how to do fly-throughs, all everything. So once you graduate, the opportunities are really limitless to you. For instance, I graduated from the program back in the mid-90s, and I thought I was just going to be making maps and you know, kind of the same traditional stuff. But you know, within a few months, I found myself living in Seattle, and I was working on a ship, building maps of the ocean floor, and it was a great experience. You know, I got to travel all over the world and see some great places. But yeah, so it's really whatever you can dream up. That's, you know, you can make that happen with the Geomatics diploma. It's pretty robust. The Geomatics program is very heavily involved with drones, where we rely on it more and more every day. But that's not the be-all and end-all of drones. I'd like to kind of talk to you about some of the other initiatives that SAIT has been involved in when it comes to drones and regarding some of the other programs. So let's take a look at some of the drones that and careers that you could be involved in. So we already talked about geomatics and how drones play a very integral part. In fact, drones are slowly overtaking that industry, just because we can do the work way faster, just as accurate, and usually a lot of times a lot safer. Because, you know, if you think of a surveyor who has to take their survey instruments out into the field and traipse through rugged terrain and all that, you know, drones, we can do that remotely without even actually having to step foot in a lot of places. So it does provide some more accessibility and some more safety. Civil engineering is another program we offer here at SAIT, and that program also relies on drones as well for the construction of whatever types of sites or structures that they're building. Pretty important with them as well. Agriculture. So farmers, this has been a big push in the last probably 5 years with farmers and drones, not only to try to map their land, but create 3D models, but also using drones for determining crop health and stuff like that. And we also have drones that, you know, pretty big ones, about the size of a box of a truck, that go up in the air and they spray pesticides and herbicides. So rather than having a tractor have to go through and make tracks and trample crops, we can take drones out remotely and not ever set foot on a field. So that's a pretty big important part. Kind of what Mike was talking about a little while ago, we do also service the journalism and TV and broadcasting programs here at SAIT. So a lot of our TV broadcasting people, whenever they're doing a broadcast, particularly outside, they always want to have some type of drone footage. And if you check out some of the different, you know, news footages on a newscast, you'll see that, you know, it's the typical camera on the broadcaster, and then they always kind of end with a drone shot, you know, showing an overview. So that's a very important part of their work as well, using drones to provide these newscasts. Robotics and virtual reality. So that's another emerging technology with drones. So I don't know if you've seen these drone races they have in the United States with the FPV drones, the first person view, but that's a very popular pastime, particularly with post-secondary colleges in the States. But we're also finding that the virtual reality is an important part of some of the stuff we're doing here at programs. For instance, if you take a look at some of these ductworks up here, you see those big where all the airflow goes through? You know, we've had a couple of big construction companies come to us and say, hey, we need to figure out how we can inspect the inside of that ductwork without pulling it apart. How are we going to do that? Well, we're going to take some of our FPV drones and try flying them in there and doing some investigation that way. So, you know, there's all kinds of things that we can use this equipment for, right? Not just surveying and making maps, but virtual reality as well. Architects are using drones a lot nowadays, particularly with reconstruction or rehabilitation projects, but drones are also great for using indoors. We've got lots of inside drones that can fly and build 3D models and make it very, very quick. So really, you know, if I wanted to build a digital twin of this room right here with a full 3D model, it would probably take me, you know, maybe 20 minutes to fly the space with the drone and maybe an hour or two to process the data. So it's very quick, and that's the real advantage to drones is the time resource, right? Forestry and environmental. So we've got an environmental engineering program here. They also utilize our drones as well to determine things like the health of the vegetation, what types of vegetation they are. But we can extend past that too. As far as forestry goes, they rely on drones a lot for forest fire detections. So drones are very good at determining where there might be flare-ups and how to, you know, deploy resources at a forest fire effectively. Search and rescue is another big element of drone work nowadays. So, you know, we don't have to send people up way up into the mountains to try to find missing people or something. We can send a drone up. They're just as effective, and the different types of sensors that we use are really cool too, because we got all kinds of thermal sensors and stuff that can do heat mapping and all that kind of stuff. Pretty effective. Police and military. So the cops are very reliant on drones now, and the military as well. So they utilize that equipment quite frequently. Okay. Any questions on that stuff? Do you guys want to come and take a look at some of our equipment? Let's come and check it out. Okay, we've got another campus out at the airport where we keep all the big airplanes and stuff in the hangar. But I've got some more drones stored out there. But this is some of the equipment that we keep here on the main campus because we use it quite frequently. But this guy here, this is called our Inspire. This is probably one of our oldest drones that we have. It's old, but it's very functional. And one of the nice things about this particular drone is that it looks pretty badass, right? And also it's very affected by high winds. It's got quite a different frame on it. You can tell it's quite skinny and slim. So that design helps us kind of resist any kind of excessive winds. And when we're flying drones, usually wind is our biggest enemy. So, you know, most of our drones can fly in pretty cold weather, and most of them can fly in rain and snow. But wind is always the big problem. Whereas this guy here, it's pretty robust in that sense. And the other nice thing about this drone is that it's also got a interchangeable camera that we can pop off different types of lenses on here depending on what we want to use it for. This one over here is one of our newer drones. This one's called our Matrice 210, but this drone is really nice because it's unique in that it's got two gimbals. So a gimbal is something that holds a sensor or a camera and stabilizes it and makes it easy to look through. So this one's got two gimbals, which is kind of nice in that we can, when we're flying it, we can capture two sets of data at once. And that really saves me a lot of time because I don't have to land, switch out a camera lens, and then fly the same area again. And actually what's really cool about this one is that I've actually got three sensors on here. So I've got a high-grade cinematography camera that we would use for shooting movies or film, something like that. And I've also got a thermal camera on here. This thermal camera has just a regular RGB lens, just like your camera on your smartphone, but it's also got a thermal lens too, so it can detect heat. So that's really, I'm collecting three sets of images every time I go up in the air with that guy. And what's cool, another nice thing about this drone is that we can fly in pretty cold weather, up to -20, because this guy here has heated battery parts. So usually when you're working with drones, a problem is the cold, because once your batteries, you probably have this with your iPhone or your cell phone, where if it gets too cold, you know, sometimes it just shuts right off, right? And then that's the battery being affected by the cold weather. So the colder it gets, the less power you have on that battery. But this drone here has heated batteries where we can fly up to -20. So the batteries actually generate heat in the drone, heats the batteries up, can keep us in the air a little bit longer. So that's a real nice advantage. If you guys want to come over here, we got a couple of kind of unique drones here. This one's our Parrot. So this one is good for many different purposes. It's got one unique feature of this drone is that it's got some pretty advanced optical avoidance. So these are our optical avoidance sensors. So if the drone's flying forward, it's actually got it's a rangefinder that determines at 3 meters it'll stop flying. So if I'm flying towards you, these things will point towards you, and when I get to a certain distance, it'll stop. It won't move because it doesn't want to run into you. And if it is going to fly downwards, the sensors move down and move with the drone. So it's pretty difficult to crash. I've tried to, but it's not that easy. So the other nice thing about this drone is these ones are all run with radio frequencies. So when I start up this drone, or any of these other drones here, I'll start up my controller, and what's happening is there's a radio frequency coming from the drone to the remote controller. Now that range is about maybe 5 kilometers, give or take, right? So it's a pretty good range, but still, after a certain distance, you're going to lose connection with your drone. This one is a little bit different. It's a 4G drone, so what it uses, you put a SIM card in the side, just like your phone, and it doesn't use radio frequencies, it uses a cell connection. So essentially, you know, if I had a friend in China who had the drone, and they had a cell connection, and I was in Canada with the controller, I could fly the drone in China from here. As long as we both have a cell connection, it'll work. So that's another really cool feature, because, you know, radio frequencies sometimes are a little bit sketchy. So but that's a pretty cool drone. This is our FPV drone. So this one's a little bit different. We don't fly it, you know, most of these drones you've got, whenever you're flying a drone, there's usually 2 people involved. You've got the pilot who's running the controls, and you've got the visual observer, which is a friend who's always accompanying the pilot, and their job is to keep an eye on the drone in the air. And you know, if there's any planes or birds coming in, then the visual observer is going to let the pilot know that something's coming. Whereas this drone here, we don't have that opportunity. We fly it through a first-person view. So we've got a camera on our drone here, and this one's nice because it's quite rugged. You know, you can bump it into things, and because a lot of the times, you know, when you're looking through here, you're just seeing what's coming through the camera. So, you know, you got to be a little bit more careful. Plus, it flies a lot faster. It's very speedy. And the other thing that's weird with this drone is that most of these drones have the same kind of controllers, right? They've got forward, backward, up and down dials on each one of them. But with the FPV drone, you're actually flying it with a stick. So your hand movements determine how fast and the direction of the drone. So it's a little different to get used to, but it's pretty fun. This is our heavy lift drone. So we use this for carrying big payloads. So we can lift up to 6 kilos on this thing. And what's really nice about this is we've got all this real estate underneath that we can mount things on. We've had all kinds of things mounted on the bottom of this type of a drone, everything from big ground penetrating radar units to water sonar units that we drag in the ponds. So this thing will lift a lot. It's got 6 different batteries, but it's a pretty big beast, but also pretty fun to fly. This one's our newest drone. This is our Matrice 300. This one is very similar to that guy there. It only has one payload, but the camera is probably one of the best cameras on the market. So the resolution on this camera is really quite unbelievable. You know, like you could fly it at, say, 100 meters above the ground, and we'd be able to see, you know, the hairs in your ear. That's how maybe not. Maybe you don't have any hairs in your ear, but that's what the cops would use. Yeah. And this would be the exact kind of system that police would use for that really high resolution, to be able to zoom in and see things from quite a far distance. And this one's kind of nice too, because it comes with a battery, right? A battery charger. So a drone like this takes 2 of these different batteries, And you know, they're pretty heavy. You know, if you feel it, don't drop it. It's heavy. It's about 1.5 kilos. So one of the batteries is about $1,500 a piece. So the drone stuff, you know, it's pricey, but if you keep care of it, it's pretty nice. This one's our dedicated thermal drone. So this one's nice. It's got 2 cameras on it, kind of like that one, but it's got a thermal camera and a regular RGB camera that's on your phone. So we use this for thermal missions. This is our main survey drone. So most surveying and engineering companies would have one of these drones. They're very, very common, and they're great for surveying and mapping and that kind of thing. And then we've got some other smaller reconnaissance drones. So these guys are quite small, but we usually use these for inspections, or if we were doing any kind of reconnaissance on a site where we can take the drone up and do a little a site check before we actually take one of the bigger units up. They're quite handy for that as well. So that's most of our equipment. Does anybody have any questions about any of this gear? Yeah.
What's the price list you would take for a lot of these?
Well, something like this drone here. So this drone here is about, the drone itself is about $25,000. The camera is about $8,000. And each battery is about $1,500. So you'll find that, you know, a lot of people will, you know, get excited when they buy a new drone because they got a new drone, but, you know, one set of batteries on this thing will last probably, with this camera on, it's a little bit heavy, probably will give you about 20 minutes in the air. So one set of batteries, you know, you got 20 minutes and then you got to charge it up again for another hour. That means sitting around for an hour, right? So you usually have to buy a few different sets of batteries, and that gets pretty pricey. So you know, usually with a system like this, all in with the drone, the camera, the battery pack, and the extra batteries, you're probably in it for close to $40,000. I'd say, yeah. So it's not cheap, but you know, we are always maintaining a very rigid safety protocol every time we go up in the air, just to make sure there's no incidents. Any other questions?
Crazy amount of planning, like before you set lift off. It's like you probably spend about 8 hours like tracking your, you know, where this thing is going to go, how we're going to get it there. Probably not just show up and like turn it on and here we go, because I only got 20 minutes, so it's like, it's probably a lot of...
That's very accurate, Mike. You know, like with drone flights, like you guys kind of might be a bit familiar with the SAIT campus. It's pretty big. It's an entire quarter section of land, so or a section of land, and so the actual flight with one of these drones, you know, probably would take maybe you know, a couple of hours, but the planning really is the biggest part of it, because, you know, when you're thinking of a drone flight, we have to make sure that we're flying within the regulations, which means with certain drones we can't fly over top of people. We have to maintain a certain height. We have to make sure that the data that we're collecting is going to be, you know, full coverage, and then we're not going to miss any spots. So, you know, on a maybe a 1 hour drone mission, I might spend, you know, 3 or 4 hours planning it, right? So, and that doesn't even count, you know, the site inspection before, because anytime I take a drone up, I always go to the site first. I do a full inspection. I make some maps of the area. So that's a lot of work. You know, you do the drone flight, which is real quick, and then the other part of it that takes quite a long time is the processing of the data, because you've got, you know, hundreds, sometimes thousands of pictures that you've got to work through and build a map from. So a lot of front end and back end stuff with drone stuff, but, you know, it's all still pretty fun.